Hi guys, this video is going to cover areas of regular polygons, which is actually chapter 10, section 3, so your note should say 10.3. And this is going to be the last section that's covered on your test, which is 10.1 and 10.3. So the first thing we're going to talk about is the parts of a regular polygon. And this is just some vocab for you. So the center of the circumscribed circle is called the center of the polygon. Remember that circumscribed is when the polygon is inside, like this one is, inside a circle where all of the vertices are actually on the circle. So if that's the case, if we could inscribe a polygon inside the circle, then the center of that circle is also the center of the polygon. The radius is the radius of the circle. It goes from the center to the vertex of my polygon. So sometimes you'll see the actual circle around the polygon and sometimes you won't. But every one of these lines that connects the center to a vertex on my polygon is a radius of that polygon. And then the last one is something completely new, and it's called an apothem. And an apothem is the segment that connects the center to the side of the polygon. So this segment here is called an apothem, okay, because it goes from center to side. Notice it's shorter than the radii because it doesn't go all the way to the vertex. So an apothem would also be here, it would be here, it would be here, and it would be here, and one more here. So there's one for each side length. It's going to have that little right angle. That tells us that it's the apothem. Again, it goes from center to the side length and it forms a right angle. We said this at the beginning, a circumscribed circle is the thing that's around the outside of the polygon. So center, radius, and apothem are just some vocab we've seen before and some that are new. That's going to help us with this section. Okay, central angles of a polygon are found by measuring or taking the 360 degrees and dividing it by n, where n's the number of sides. So if I was trying to find out the central angle in a triangle, for example, n would be 3, and I would do 360 divided by n or divided by 3, and I would get each central angle on a triangle would be 120 degrees. So if I were to draw this, this would be 120 degrees, this would be 120 degrees, and that would be 120 degrees. Those are the central angles of a regular polygon. All right, so example 1 says, find the measure of each numbered angle of my polygon. So I'm going to zoom in on this a little bit. So the number 1 is here, and that's your central angle. So in order to find the measure of the central angle, we're going to do 360 divided by the number of sides. There's 1, 2, 3, 4, 5 sides here. So I'm going to do 360 divided by 5, which is 72 degrees. So that's angle 1. Now if I take one of these triangles that are formed by my central angles, and I cut it in half like this is done with my apothem, it takes that big central angle and cuts it into 2 equal parts, which means to find angle 2, I'm going to do 72 divided by 2, and I get 36 degrees. So this angle in here is 36 degrees. Now the third angle I want to find is here in this corner. Hopefully you see that what's formed here is a right triangle. I've got my 90-degree angle here, 36 here, which means if I want to find angle 3, I would do 180 minus 90 minus 36. 180 minus 90 is 90. 90 minus 36 is 54 degrees. So angle 3 is 54 degrees. This was angle 2. So to review that process again, we did 360 divided by the number of sides, which in this case was 5, to get angle 1, which is also this big angle here. The apothem cut it in half, so we divided the 72 by 2 to get 36. And then we formed a right triangle here, so we subtracted the 90-degree angle and the 36-degree angle from 180, and I got that last remaining angle is 54 degrees. Okay, now let's talk about the area of a regular polygon. So if I want to find the area of this polygon, first of all, the word regular means all sides are equal and all angles are equal. This formula only works for regular polygons. And the formula is half the product of the apothem and the perimeter. So there's two formulas you can use. 1/2 A times P, where A is the apothem and P is the perimeter. Or, if you didn't find the perimeter already, you can do 1/2 N times S. N is the number of sides, we already said that, right? And then S is the length of each side. So N times S is the same thing as perimeter, which is why you can use either one of these formulas. So if I was to find the area of this polygon, I would have to know what A is, I would have to know what S is, I would have to know the number of sides, 1, 2, 3, 4, 5, 6 this time, and then I can do 1/2 A, N, S, or you can do N times S to get the P and just multiply by that. All right, let's look at some examples of area of a regular polygon. Example 2 says, find the area of each regular polygon with the given apothem A and side length S. So apothem is A, side length is S. Area, because we don't have perimeter, we're going to do 1/2 A, N, S. So if you look at A, it says a hexagon. Already there I know N is 6. A is 6 and S is 6.9. So I'm just going to do area equals 1/2 A, which is 6, N, which is 6, S, which is 6.9. Now the good news is, again, on this test, you're going to be able to have your calculator. So I can actually type that all in together. I can do 0.5 times 6 times 6 times 6.9 and let the calculator do the work for me. And I get the area is 124.2, and it would be centimeters squared for the units. B is an octagon, which means N is 8, S is 5, and A is 3. So again, area equals 1/2 A, N, S. 1/2 times A, which is 3, number of sides, which is 8, length of each side, which is 5, and on the calculator, I'm going to type in 0.5 times 3 times 8 times 5, and I'd get 60. This time there's no unit, so it's just units squared. All right, that's it. So the biggest takeaways here are the measure of the central angle is 360 divided by the number of sides, and then the area is 1/2 A and S. Another thing you might want to review are the names of your special polygons. So remember, 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, there's nothing for 11, and 12 is a dodecagon. Everything else, it will say something like 17 gone, and you would know that 17 is the number of sides. So central angle, 360 divided by the number of sides, and the area of a regular polygon, 1/2 ANS. You can add those to your notes for your formula sheet, anything like that, which will help you when you take your open note test. That hopefully is answering any questions you've got. That wraps up this section, and obviously the first 3 sections, which is what your test is going to be on. Have a great day, guys. Make sure you submit your notes.